Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be learning how to write an exponential function if we're given a table or a graph. Before we start, let's look at the steps to working out this process. So in step one, you want to identify what we call the initial value of the function. It is the value of y where x is equal to 0. Or in a graph, it's where the function crosses the y-axis. Now, you generally have heard the initial value referred to as the y-intercept of the function. All right. The second thing you want to do is identify the common ratio, or what value are y's being multiplied by. What value are the y's being multiplied by? Step 3, you're going to use the values of a and b to write an equation of the form f of x equals a times b to the x power. Now let's look at these steps in action. So in example 1, it says write an exponential function to describe each of the following. So in problem A, we already know it's given to us that this is an exponential function. So the first thing we want to do, step 1, is identify our a. So we look to see what is y when x is 0. So from our table, we can see that when x is 0, the y value is 2. So that's your initial value of the function. To find your common ratio, you take the second value, which is 8, and divide it by the first y value, which is 2. So 8 divided by 2 gives me 4. So our common ratio here is 4. Each y value is being multiplied by 4. So our function here would be f of x equals our initial value, which is 2, times our base, which is 4, to the x power. 2 times 4 to the x power. All right, problem B. Here we're given a table. We're told it's an exponential function. They want us to write a function rule to describe the values in this table. Now, the difference in this table and the previous table is they did not give us x equals 0. So when that happens, you need to find the y-intercept on your own. So I could put a 0 right here, and then I could use the pattern in the table to find the y value. So let's look what's happening here. When we go from 4 to 8, that's doubled. 8 to 16, doubled. 16 to 32, doubled. So to get this value, we know we have to double the 32, which would be 64. So our a value, our initial value, is 64. All right. Now, to get your b value, I'm going to use this term and this term. Just take 32 divided by 64, and we get 0.5. So you can write it like this, or you can write it in fraction form. So f of x would equal 64 times 1/2 to the x power. 64 times 1/2 to the x power. All right, problem C. We're given a table, and we're told it's an exponential function. They want us to write a function rule. But again, just like the previous table, they're not giving us the initial value. So I've got 1, 2, 3, 4. So I'm going to need to back up one place to get the 0. So let's look what's happening to our y values. It looks like 16, I would have to divide by 4. 4 divided by 4 would give me 1. 1 divided by 4 would give me 0.25. So what I need to do is take 0.25 and divide it by 4 to get 0.0625. So there is my initial value. Now, to get your B value, I'm going to use a little bit easier ones right here. We have 16 and 4, so I'm going to take the second one, 16, divide it by 4 to get 4. So our rate of growth is 4. So our function rule here would be f of x equals 0.625 times 4 to the x power. All right, next problem. First thing we need to do is find our initial value. So we need to figure out what is the pattern here. So we have 65, 61 divided by 72, 90. So they're dividing by 0.9. 7290 divided by 8100. Whoops. 7290 divided by 8100 gives me, they're dividing by 0.9. So to get my next value up, I need to take 8100 and divide it by 0.9, and that gives me 9,000. So my initial value in this problem is 9,000, and my base, my common ratio, is 0.9. So my equation would be f of x equals 9,000 times 0.9 to the x power. All right, now let's talk about what to do if we're given a graph to write the exponential function for. We start out the same way. We want to identify the a value, the initial value, or the y-intercept. So I'll put a dot right there. So in this problem, our initial value is 12. Now, to get the common ratio, you're going to need to make a table. So I know my initial value is at 0.12. We want to find another friendly point on this graph. So the only one that looks friendly to me is right here, and that would be 1,8. So if we want our common ratio, we would simply take the 8 and divide it by 12. So put that in your calculator. And you want it in fraction form. We don't want to round anything. So our common ratio is 2/3. So my function rule would be f of x equals 12 times 2/3 to the x power. All right, problem B. Again, we want to start out by getting our initial value. In this problem, it looks to be 6. And again, when you're given a graph, it's very important that you make your own table. So we're looking for a friendly point, and the only one I'm seeing there is this one. So that would be what? -1, 4, and then we have 0, 6. All right, so to get your common ratio, you take 6 and divide it by 4, which would reduce to 3/2. So our function will be f of x equals 6 times 3/2 to the x power. Now, before we finish, I want to just show you some examples of how this will be tested on standardized tests. So look at example 3. The table represents some points on the graph of an exponential function. And the first thing I want you to do is look at this function and ask, is it increasing? Are the y values getting bigger or are they getting smaller? So this is an increasing function, which means your base must be greater than 1. So generally what you can do is eliminate some bad answers by looking at the bases. Our base must be bigger than 1. So in problem A, our base is 3 over 2. That's bigger than 1, so don't eliminate that. In B, our base is 2/3. That is not bigger than 1, so get rid of that answer. C, our base is 3 over 2. Keep that one, it's bigger than 1. And D, our base is 2/3. That is not bigger than 1. So eliminate that answer. So we now know that our function rule is either going to be A or C. So the next thing we want to do, you know what, let me write this. Let's see. All right. So the next thing we want to do is get our initial value. So this would be, whoops, I need a pen here. This would be 1 something, and this would be 0 something. So we're going to have to go back to. Okay, so let's see what they're going back by each time. 121.5 divided by 81 is 1.5. 81 divided by, 81 divided by 54 is 1.5. 36 divided by 1.5, that would be 24. Go back one more time. 24 divided by 1.5 would be 16. So we now know our initial value is 16. Therefore, we have to go with answer A. All right. Example 4, an exponential function is graphed on the grid. Which function is best represented by this graph? So the first thing you want to do is ask yourself, is this exponential function increasing or decreasing from left to right? So we can see it's decreasing, which means our B value must be between 0 and 1. Our base has to be smaller than 1. Let me say that again. The base must be smaller than 1. So I can get rid of C and D because they have bases that are bigger than 1. All right. The next thing we're going to do is identify our initial value. So our initial value is the y-intercept right here. So A is equal to 1 in this problem. So that now allows me to eliminate answer choice B. And I know the answer is answer choice A. And that concludes today's lesson, writing exponential functions from tables and graphs.